new posters. So this is Tuesday Tech Talk. We do this every Tuesday at lunch, where we have a speaker from one of the WeWork companies or from anywhere that has anything interesting to say. We'll do a 45, 30-minute talk with the community. We provide lunch. It's put on and sponsored, and pair between WeWork and Pivotal Labs. So WeWork is either provider of the building and space we're in. Pivotal Labs is an agile software consultancy. We take up a bunch of space on the 11th floor down below. As mentioned, this is Tech Talk. If you want to give a Tech Talk, send an email to that email address. If you have an idea for a topic that you would like to see covered at a Tech Talk, also send an email. We'd love to have suggestions. We'd love to have speakers. If you think of somebody who would give a good Tech Talk, volunteer them, and I'll reach out and get in touch with them. If you have a company or a product that you're looking for a little bit of professional advice on, we do this thing called office hours. You can check out productlabs.io, fill out a form there. We do free consulting for startups that have very specific problems, so feel free to hit that up if that's a resource you could use. And this is a community event that we would like to grow. So anybody that you think might be interested in coming to check out and get free lunch, bring them along. We would be thrilled to have them here. I'd like to be in a position where we can't do it here anymore because there's no space. That would be a good problem to have. So cool. Just dive right into it here. Virtual reality and augmented reality is something I'm really crazy, nerdy, passionate about. I wanted to give this talk for a while because these are buzzwords that are going around in the tech world right now, and there's a lot of jargon, and there's a lot of slang, and there's a lot of terminology, and I want to provide kind of some foundation information. So when you hear somebody say AR, you can at least say, oh, I know what that means. So that's kind of the basics I want to cover. Then I want to get into what the landscape looks like today. This is real, this is not in the future, this is not technology your kids will play with, this is the now. And then I want to talk a little bit about why we should care, right? VR is way more important than just the gamers in their basements disconnecting from reality. There's some real applications here. So let's talk about some of the basics. Virtual reality is what I want to start with. This is what you're all probably most familiar with. You've got the big dorky headset, like what I've got here. Strap it on, you can sneak up behind me, and I have no idea you're there, right? Virtual reality is a complete replacement for the environment that you're in. So an important concept of virtual reality is full immersion. You're not seeing anything from the outside, you're not seeing light from the outside. It's a complete panoramic view of this created environment that's in front of you. So with full immersion, the key aspect of virtual reality is the sensation of presence. So if you hear people talk about presence with relation to virtual reality, what they're talking about is your mind's ability to actually believe that you are in this different environment. There's a couple things associated with that. The first, believe it or not, it has nothing to do with how realistic the visuals look. In fact, a lot of studies have shown that if the visuals that you're in are too close to reality, then your brain is better at picking out flaws and better at convincing you that this isn't real. So you'll see a lot of cartoony or stylized approaches to visuals in virtual reality that are just as good at imparting the sense of presence. Another thing that's important with the sense of presence is latency, which is just a fancy word for how fast do things update to your eyes. So your eyes are very powerful organs, and they can sense anything that's not realistic, that's not smooth movement, will throw you off. So in a device like this, like what I have here, this actually uses your phone as the engine behind the virtual reality, but it has its own sensors in it that are calculating for your head movement. Because the phone sensors, while they're good, they're not strong enough, they're not accurate enough to reduce the latency so that when you turn your head, you get it moving exactly along with you. If you turn your head and it lags behind a second or a millisecond, your eyes notice and it will make you sick. So there's big players in virtual reality. There's Oculus, which had a super successful Kickstarter, then was acquired by Facebook for $2 billion. That's with a B. And that's having not released a single consumer product, $2 billion, right? So Facebook obviously sees a purpose for this. Valve, for those of you that play video games, Valve used to make some really great games. Now they run this storefront. They designed this system that HTC, the phone manufacturer, built the first prototype of. So there's like some serious weight in from the game industry there. AMD has a play in virtual reality, partnered with a Canadian company called Suwon. And NVIDIA makes the graphics chips and just about everything. Also has a big hardware play with virtual reality. Now there are multiple flavors of it. What I have here is it's a phone-powered experience. So you buy the shell, and you stick your phone in it, and it renders the environments for you. There's the tethered experience, which is like the Oculus, where you've got the headset and all of the cables that connect it to the computer. These are typically the highest fidelity solutions for virtual reality. And then you have these standalone experiences. So I mentioned AMD's partnership with Suwon. So Suwon is a standalone experience where it's got the headset, and the computing engine is actually attached to the back strap to the back of your head. So you don't need any other technology, it's just the headset. Any questions about this before I move on a little bit? Cool. So this is an example of virtual reality. And I'm not going to play any audio with it, but I want to talk through a couple things that you're seeing here and why it makes such a big deal. This is a product called Job Simulator. And the concept behind this is that it's in the future, humans don't work anymore, so they created this simulation of what they thought jobs were like back in the day when people had jobs. So what you're seeing here in the bottom right corner is actually the human in the experiment. This is a view of what he's actually doing. And then this is what they're seeing. And in the bottom left corner is what the camera from the lenses are seeing. So as you can see, he's got hands. He's got the ability to use his hands. And he can pick things up. And he can throw them. He can juggle. This is the type of technology that you get with virtual reality. Right? I'm going to pause this, move on here. And I'm going to talk about input in a second because it's really important. But what you're able to see there is a person can see a thing, can reach out, can grab the thing, and it reacts exactly how they expect it to. So some benefits of virtual reality is that you are there. This is not an overlay. This is not something that you're approximating. It's you are there. Wherever there is, there you are. For development, it's very similar to building video games. You can use the same game engines. There's subtle differences that start to become more impactful differences as you go. An example of this might be in a regular video game, you would have all of these items sitting on a desk are static, like you can't interact with them. But in a virtual reality experience, you expect to be able to go and knock something off of the table. If that doesn't behave that way, then you're immediately thrown out of the experience. You can experience real things that are out of your reach. So there are virtual reality vacation companies now, right? Where you can set up at a beach cabana somewhere, sitting in your office with a goggles on. Right? You can experience things that are impossible, such as what would it be like to be an astronaut on a faraway planet, right? We can simulate the physics, we can create that experience such that you can do something that you will never be able to do in your lifetime. And other interesting thing about virtual reality specifically is that it touches on your mental, emotional, and physical traits, right? So part of it, again, being presence, the feeling like you're actually there. When you couple that with strong input solutions, you're actually doing the interactions, and it can leave you with, if you want to Google for some of the jump scares that people do in virtual reality, you will see that there is an emotional investment as well. Some of the challenges: it's expensive. To get the really high fidelity virtual reality, you've got to buy a headset. The Oculus Rift costs $600. You have to have a beefy computer such that it can drive the Oculus Rift. That's probably another $1,000. Or if you're going to have this type of solution, you have to have a very specific model of cell phone in order to run that headset. Related to that, that there are multiple platforms and no standards. It's kind of the Wild West right now. So if you build a thing for this headset, it's not guaranteed to work on this other headset. So there's these sort of platform dependencies. If you build bad VR, you can actually make somebody sick. So this isn't just a matter of like, I don't like it. This is a matter of this made me sick. So like as software creators, there's a responsibility to not make bad VR experiences because you will ruin it for the rest of us. It's also really easy to build bad stuff. You'll see this like as software development gets easier and gets more forgiving. Like the ability to create bad stuff also gets easier. You'll see this on the App Store with your iPhone, right? There's a whole bunch of junk games on the App Store. With virtual reality, that's like augmented because now there's all these pieces that have to come together to create a good experience, and it's really easy to build it poorly. You wear a dorky headset. I don't know how many times I've had my headset on and my wife, like I can just sense her like shaking her head, like I can't believe I married this person. And like it's kind of comical, but it's true, right? For it to get to like a mass adoption, like the dorkiness needs to be reduced. Possibly because of the dorkiness, current iterations of virtual reality is also targeted toward gamers. A couple of reasons for that. Gamers have discretionary income that they're used to spending on things like that. Most gamers are antisocial from the perspective of they play in a solitary environment. So it makes sense. This is where we're going to market first. And then there's simulator sickness. And I want to talk about this because there is a difference between sim sickness and motion sickness. So simulator sickness is where your eyes are saying, hey, I'm moving, and your body's like, no, you're not. We're just standing still. Motion sickness is where your body's like, guys, we're moving, and your eyes are saying, no, we're not. Everything's fine. So like when you're on a boat and you're seeing out in the distance, it looks fine, but your body's moving. So there's the disconnect there. It's different. One can affect a human without the other one affecting a human. And also interesting, a fun fact about this, is most forms of this, of simulator sickness or motion sickness, don't affect people until about the age of 13. So you'll see like younger students and stuff in classrooms, they'll go through a virtual reality experience, no problem. The teacher, on the other hand, may experience some signs of sickness. Augmented reality is the next step that I want to talk to. Augmented reality still has dorky headsets, except now they're see-through. You can't really tell in the projector. These are all see-through. So you can, it's an overlay on top of the environment around you. It's very contextual, so you'll see use cases where it's like I'm looking at a tool and it's giving me like the information about it. Who's the manufacturer? Like how much does this cost? Like it can be very contextual. Analysts predict this is the long tail. This is going to be the part of the new reality industry that is going to have the most commercial applications. It's going to be the most useful in regular life. So this is where a lot of the investment is going into the research of augmented reality. And there are some really big players here. So Microsoft has the Hololens, which you can buy a development kit right now for $3,000. Magic Leap. Has anybody heard of Magic Leap? A couple. So Magic Leap is based down in South Florida. They have raised $1.2 billion of funding and have never shown the product they're working on. Nobody has any idea what it looks like. We have some guesses about the technology, but they were managed to raise $1.2 billion in venture funding without having a product that's visible. Google also had Google Glass, which is a form of augmented reality. And then there's Metavision. Metavision is a startup based in Silicon Valley, and they're a competitor to Microsoft in this exact same space, but they're like the scrappy startup version. So this is an example of the HoloLens. I'm going to see where we're at here. So what we're seeing, Microsoft built a camera rig that allows the camera to see exactly what's being projected in this augmented environment. So what you're seeing is you have the real world, this is a room, and there are these overlays, these digital overlays that can be placed in the environment. So you've got this guy here, and he's got his little dog, and he's got this floating panel. And the idea behind Microsoft's version of augmented reality is I can say, I want to open up my Skype window, and I want to stick it on this wall. And then I'm going to leave the room. And then when I come back in and I look at the wall, my Skype window's there. So it's about integrating your digital life with your real life. It's not about replacing your real life. So you're saying he just popped up his Skype window, he's going to turn it, and he's going to place it on the wall over there. Yeah. So pretty cool stuff. Some of the benefits, as I mentioned, it adapts to your real world. It's not a replacement. You don't have to be completely disconnected in order to have the benefits of augmented reality. It's a similar development process to current applications. I wouldn't say it's similar to game development. It's similar to like building a mobile app or building a Windows application. In fact, all of those applications you saw on the Microsoft demo just now were made using the Universal Windows platform, so JavaScript writing the application. One of the big visions for augmented reality is that it's going to improve the things that you already do. So it's like superpowers for your regular life is kind of the goal. It is less intrusive, again, because you can still see everything that's going on around you. And it leverages you as input. And I'll talk about this in a second. Some of the challenges, again, cost. Hololens, $3,000 for a development kit. Metavision is $950 for a development kit. We haven't figured out input yet. You'll see there's no standards for input, so you'll have some people that are like, look at the thing for 3 seconds, and then it'll become active. You'll have some people who are like, stick your fist through the thing, and then pull it out and twist, and it becomes active. So we haven't figured out input. Part of that is because there are multiple platforms, everybody's doing their own thing with their own research. It's still a dorky headset, right? It's just less dorky, but it's still a dorky headset. And this is not marketed to gamers. Gamers have no interest in this type of technology because they're looking for like the Star Trek holodeck type experience. The interesting thing about this is that with augmented reality, we haven't identified who like the hardcore buyer is going to be from a consumer perspective. From an enterprise perspective, they're gobbling this up. But if you want to get it mainstream, if you want to get it to the type of thing where people are excited to be augmented reality developers, then there has to be things targeted toward it. So that's a challenge that we're still encountering. Input. This is my favorite thing to talk about because it's the hardest problem. Right now, today, in the world of virtual and augmented reality, there are controllers, like what I brought here. Anybody who's ever played a video game, it's a controller, exactly like you would imagine. So that's being used. There are motion controllers. You can think like the Wiimotes, which you wave around like wands. There are gloves that will track your finger input. There are treadmills like this. I have a video of that later. But this treadmill is supposed to track how you walk in your direction, so you can move in the experience without actually walking around the room. There's voice activation, which is pretty standard. There's camera activation, which you've ever used like a Kinect or something with the original Xbox or the Xbox 360. There's that. And then there's these crazy haptic devices. These are my favorite. So I've seen like full body vests that like you'll get shot in experience and then it'll vibrate. That's kind of cool. But the coolest thing I've seen is it's a glove that has these motorized sensors that stick out apart from your fingers. And when you touch something in the virtual reality game, those sensors will push against your finger and it'll vibrate with like an appropriate texture of what it is that you're touching. So it's like the harder you push, the harder it pushes against your finger. If you slide your hand along it, it'll vibrate in a specific way. And they have over 100 different materials that it simulates. So it's like wood, concrete, steel, etc. Pretty cool stuff. This is my favorite video example though. This is a hand tracking technology, and this is really cool. So Leap Motion makes this sensor that you can buy for your desktop right now. It plugs in front of your desktop and you stick your hands in front of it and you can interact with stuff. So somebody decided to take one and tape it to the front of my headset. And this is what you get. This is a real demo. This is real time. You can actually download this demo right now. But these are your hands as represented in 3D space. And the person is able to grab stuff in the virtual environment and use your hands exactly how they're intended to be. So there's some really cool applications of this. One of the important things to realize is that us as humans are not great at doing this type of stuff. We're really good at manipulating our hands. So you're going to see a lot of technologies that are going to mix both of those. This is natural input for us. This is not gesture-based input. This is us doing what we think we should do. I'm actually going to keep going. It's cool, but you can look that up in your own time. So the benefits of this is you can be the controller. What that means is it lowers the barrier to entry of people using technology. Like, my mother does not use smartphones. She doesn't play video games. So trying to get my mom to understand how to use a text message on an iPhone is a really complicated concept because she has to learn the language of interacting with the touchscreen. In these types of environments where you are the controller, like, you're just being you with the software. So there's really cool opportunities there. You can interact with things intuitively. You know, if I see a cup, I want to be able to reach out and pick it up, right? I don't want to walk over to it, bring up my menu, hit the character grabs it. We don't have to worry about that anymore. It extends your natural capabilities. So an example of this would be, there's a surgeon in California. He's an expert, and we have him strapped up to a innovative input rig, and there's a surgery happening in Philadelphia. We can actually have the robot sync up to the behavior or to the actions that the surgeon is doing. So this is a technology they're currently prototyping with right now. And then you can replicate your behavior somewhere else, which is kind of what I just talked about. Oh, the extend natural capabilities would be something like, you know, I'm going to look at this table and I want to pick it up. So I'm going to make the pickup motion, and whatever sensors are like hydraulics around the table will actually leverage it. So it's taking my intentions and having them done elsewhere. Challenges with this, recurring theme, it's expensive. Costs a lot of money to do some of this input stuff. The treadmill that I showed you earlier, $700. Right? There's no standards for this again. How do you deal with people with disabilities? You target your application towards a specific input that requires a specific amount of mobility, like you've now alienated a percentage of your users. Interpreting attention is a very difficult thing to do. So it's like one of the things that happens a lot as a human being is we'll say something and go, oh, well, that's not what I meant. Well, we do the same thing with our motions, except with our motions, it's really easy to correct it. So it's like I picked up a pen, oops, I meant to get the pencil. All I do is put the pen down and pick the pencil up. In a simulation, we have to account for that type of concept, right? Of having a human, like, either understanding what their intention was or having them correct their intention as they go. Breaking immersion is a really big topic with input because the second something doesn't react the way that I expected it to, I'm gone. Like, I'm not there anymore. Like, if I reached out to grab this controller and I made this motion and it didn't pick up, I'm completely disconnected. Physical space is also an issue. The treadmill that I showed you probably needs a space like this big to exist, so it's not something that you're going to have in your living room. And then there's input jargon. So treadmill, well, what's a treadmill? It could mean there's versions of it that it's actually a treadmill and the ground walks as I walk. There's versions of it where it's like a concave surface and I actually slide from front to back on it. There's some of them where they're just a pad on the ground and I actually shuffle my feet back and forth. They're all called treadmills, but they mean totally different stuff. So for anybody who's not up on this information, like, the jargon is a big deal. Cool. The current reality behind this is that today you can buy commercial version virtual reality headsets. Like, you can go online and order something that has been built for humans to use, not researchers, not laboratories, not scientists, but actual end users. You can go purchase this stuff right now. You may not get it for a while because it's back ordered, but you can go buy it right now. The early reviews are really positive. Everyone says, oh my gosh, this is fantastic, but the software is lacking. So it's like you have this great new innovative platform, but then you're playing like the equivalent of like the original Mario Brothers on it, right? It's early days in software development. And this is a cyclical problem because, like, I'm not going to invest a lot in building software until there's enough people that are out there to buy it. Well, I'm not going to buy it unless there's stuff worth buying on it. So there's this cycle that needs to be broken. Too small of an install base. Enterprise customers already have solutions that technically are way behind the times, but if I'm a Boeing or Lockheed Martin and I invested $500 million into my own VR training simulation, I'm not going to want to switch to an $800 superior replacement, right? There's a sunk cost associated with that. It's unfortunate, but it's true. So analysts are predicting the VR market is ultimately going to be the smaller portion of the new reality market. They're expecting by 2020, I think the market to be like $17 billion, and they're thinking $6 billion of that will be like virtual reality. And it just costs a lot to build this stuff, right? Like creation of art assets is expensive. The input is expensive. It's tough. It's hard to justify that cost with the small install base. So while VR is here today, augmented reality is still in the future. If you can buy some experiences now that are really terrible, it'll make you say, what's the big deal? But this is the future. This is where we will be going. Microsoft, Metavision, have dev kits that you can buy. That you can order them now, and you'll get them by the end of the second quarter of this year. So it's an interesting opportunity for software companies to dabble with. At Microsoft's latest Build conference, they had a bunch of customers come out on stage and talk about how they were supporting AR and things they were using for it. Like NASA was there to talk about like repairing the Mars rovers. And there was all sorts of cool stuff that's happening. So this is like the big bet for the future. Talked about Magic Leap already. It's more practical, but kind of less attractive at the same time than virtual reality. So there's like this weird world, like how do we make it more exciting for people? And again, we predict this is where the money's going to be. So all of this has brought us to some hard truths about the current realities of this market, is that we need better technology, right? Hardware needs to be better and it needs to be cheaper. When smartphones first came out, there was like this fascination with let's make it faster and smaller. We're going to have the same cycle with this type of hardware now, where we're going to have the giant video cards that are this big need to be shrunk down to like fit in your pocket or something to drive the lenses that you're looking at. We need better battery power. My Gear VR lasts as long as my phone does, which is only a couple hours if I'm using virtual reality. Things need to be smaller. The optics need to be better so that our eyes are actually seeing what we expect to be seeing, not like individual pixels. We have to solve input. It has to be less dorky. It really has to be less dorky. And we have to figure out the development process. Like, building software for this can't be hard. It just can't. We also don't know enough about how people are going to use it yet. Like, we know how I'm going to use it. Like, I'm going to play video games with it. That's what I'm going to do. But there's a whole host of other applications. We're just not sure how people are going to do it. Final bit, why we should care. So this is a little bit future-looking in some ways, but an important thing with virtual reality and why we should care about it is this concept of presence that I talked about earlier. So you can imagine a situation where you strap on a headset, and if you wanted to partake in the experience of like the Roman Colosseum, as exactly as it was, then we can recreate that. We can actually put you there. And with the technology we have today, like everything can now be recorded in 3D, such that anybody tomorrow can relive any experience that happened today. So this is going to be really interesting when we start talking about looking back on history. Like a lot of the things that are currently open for interpretation, we'll actually be able to relive, and that'll be really powerful for education. So opportunity to overcome fears. So my headset actually has a public speaking application on it, where it's like you stand up at a podium, you have your slides in front of you on a monitor, but there's a room and you can adjust how noisy they are or how many people are in there, and it's like you're standing up talking to this group. It's pretty cool stuff. I don't necessarily have fear of public speaking, but that's something that you can do. Empathy is interesting. So there's, in the NFL, they're doing this with race. So like being able to put their white players in the role of an African-American player out in public, for example, and seeing how like the simulation interacts differently based on skin color. So there's a lot of interesting applications there that allows you to be put in the shoes of somebody else and how you can interpret that. Practice and training, pretty self-explanatory, right? Like I'm in this thing, I can pretend like I'm pitching in the World Series and have that type of environment out. Learning games. So lucid dreaming is something that a lot of like top tier people talk about doing, where it's like the concept of like practicing while I'm sleeping. Well, this is kind of the same thing in the sense of I can do things without doing them, but in the real environment, so I learn things faster. It's an assumption that they're still testing, but there's a lot of research going into using virtual reality to make things stick and to learn things faster. Augmented reality, I refer to it as like human superpowers, something I'm really cool about. There's this concept that I call computer vision, where it's like I want to be able to look at this table and say, okay, Google, I want to buy that table. And it looks at what it is, and it says, oh, it's this model. Here's where you can get it from. Here's the size of it. That probably won't fit in your office, because here's the dimensions of your office. But being able to do that at any point is really cool. For teaching, kind of the same thing, where like I could be looking at a classroom full of students, and I could get, like if I'm a substitute, I could look out at the classroom full of students and I could have the names pop up over everybody. So I don't have to keep forgetting everybody's names. Translation is really cool. You have those like lens apps on your phone where you can take a picture of a thing and it'll translate it to your language. Well, here you can do that with removing that entire step. Like you can look at a sign and whoo, here's what it means in English. Like that would be pretty fantastic. And that goes along with the concept of freeing the hands from the phone screen. Right now, for us to access the internet, we use our hands, which completely takes it away from being useful. So if we can have a scenario where we have access to information without needing to use our hands, it's pretty fantastic. One day these will be powered by the phone in your pocket. I personally believe that one day everything that you own will be powered by the phone in your pocket. It's just going to be like this utilitarian brick that you're going to plug into your desktop when you get home, or you're going to take out and then you're going to plug into your workstation when you get to work, or you're going to plug it into your headset, and it's going to be the driver to everything that you have. I will take bets on that if anybody wants to get in on that. It's also a really interesting opportunity to share your world and to see somebody else's. So an example they had that Microsoft showed off was repairing like an electrical socket. So it's like I could call a repairman, he could view things through my eyes and walk me through what I'm doing. So it's like, I don't know what I'm doing, and I have this guy tell me, oh, you want to take that blue wire and you want to move it over here. And he doesn't have to be there. I have this new ability because of this technology. And then there's also the limitless brain, right? The idea behind the limitless brain is that access to information has continuously been easier to get. Like Wikipedia has everything, right? But that's only when you have your phone out in front of you. Do you have access to all of that? Now we're reducing that barrier such that you always have access to all of the information. Some of the opportunities, I look at this from a business standpoint. If I were to invest in building a company right now about augmented reality, virtual reality, there's going to be a real need for art assets. You can think of this in terms of how many different versions of a ficus need to exist, right? Let's just make one. Anybody who needs a ficus can use the ficus in their application. There's also an interesting opportunity of quantifying humans. So with video games, we are minimized in what we can learn about people because there's a set of things they're allowed to do in the game. With a virtual reality experience, however, we're able to learn a lot more about stuff. We're able to learn a lot more about how humans interact with stuff. What did they look at? What triggered them to look at? Did they look at things because it shined, or did they look at things because they heard an audio cue? Like this type of technology is going to allow us to capture a whole lot more of what it means to be a human and how we interact with things. I already talked about phone as the brains. We need to redefine how the software is being created. There's this example that I'll show you in a second. But if we are creating this 3D interactive content, why are we doing it at a 2D workstation? Interaction frameworks. So if I'm a company that wants to come and have an application built, I'd like to be able to check the boxes of the users are going. I need them to use their hands. I need them to see the outside environment, and I need them to. They're going to be standing in place. I want to check these boxes, and then I want to have like my application framework kind of spun up for me, so that I don't have to think about rebuilding all of those core concepts. The intersection of simulation and web mobile is something that is interesting. So there's a lot of companies that are good at building games and simulations. There's a lot of companies that are good at building web and mobile products. Those are not the same companies. So you're going to have experiences that are really heavy on one end, really light on the other, or really heavy on this end, really light on the other. We need to bring those two concepts together if we're going to create truly great experiences. There's also this new gold rush. Customers with deeper pockets is maybe a less correct way of saying enterprise customers. This is where the money's at right now. Every enterprise has a need for this type of stuff, from their employees in the stock rooms of being able to like get the map of, I'm taking this box, where am I taking it? I'm just going to follow the directions. It's going to improve efficiencies. Like, this is going to be used, not consumer facing, this is going to be used to cut costs, improve profit for enterprise. That's how they're looking at this right now. Cool. I have a couple more videos that are more for fun than anything else. So while these are playing, I'm happy to answer any questions you might have. Yes?
I'm really curious about advertisers and advertising within AR and VR, and if that's already happening.
So there's concepts around it. Right now that includes things like, I'm Tide, and you know, there's a bottle in front of you. Pick it up and turn it around and see what coupon you unlock. So it's going to be about, are you interacting with my brand rather than are you seeing my brand? So it's going to be less about this impression focus that we get now and more about drawing their customers to interact with their brand. So there's research going into this, but because there's not a huge platform or a huge adoption yet, it's not been real big. And I would argue that there's an opportunity for a company to fill that void by saying, we're going to build out the capability, we're going to build out the frameworks, and when the scale is ready, everybody's going to come to us.
Yeah.
Other questions? Oh, this is Be a Bird. So this is done by some students. They use this hydraulic machine that adapts to how the person is steering their hands, and it actually lifts or lowers the body, and they're seeing things through a bird's vantage point as they fly through the city. So you actually have to flap in order to go up. It's pretty cool. They're talking about that a little bit there. Other questions? Well, this was the video I wanted Sam to see. So this is an app called Tilt Brush. Tilt Brush is a painting app. They allows you to paint in 3D space using like brush strokes with a wand. They gave this to an artist, and this is what you're seeing here. This is a traditional 2D artist that's able to paint and then walk around the thing she's painting and add paint in depth at another angle. So she's able to like pull a stroke toward her, away from her, up and down. It's really cool. They gave the same application to a 4th grader, I think it was. The very first thing they did was they painted a 3D igloo and crawled inside it. So it's like when we talk about new ways of building content and assets, like this can completely change everything. And again, now the 4th grader didn't have to learn a complex tool like Maya or 3D Studio Max to build 3D art. They just painted in space. So really cool stuff that are coming. I think I have one more because you guys are so quiet with questions. Oh, augmented reality. So this was an April Fool's joke from the Meta company. But it actually has some interesting things associated with it, right? So for us to be able to understand like what it is that our pets are attracted to, or what is it that they're doing during the course of the day, what is it that they're seeing that maybe I could like direct their attention toward. Augmented reality is totally a joke, but it does bring the question of what other things are there that like this type of technology is going to allow us to do? I don't know. But some of the whiteboard drawings, you should watch this video when you get back at your desk. Some of the whiteboard drawings in the background are pretty sweet. Was there anything else? No, questions?
What's an example of an enterprise client that's using virtual reality?
Sure. So I don't know the specific name of this because Microsoft just mentioned it on stage, but there's a customer that's using this for data visualization. Actually putting the human in the center of looking at the data. So rather than relying on like a computer to draw conclusions behind the stuff, it's kind of this type of experience where I can find this node here and I can visually trace back like all the things that it touches and may be able to draw new conclusions that like a computer wouldn't have thought was interesting or something that we wouldn't have known from looking at just like a spreadsheet, right? So that's one example of an application. Another example, Boeing is working on this tool that allows them to think about how they're going to repair their craft before the craft gets built. And this came from a simple example. Here is the ship. We want to fix the ship. We can't fit the wrench through this hole, so now we can't fix it. With an augmented reality or virtual reality solution, you could equip the wrench, see if it fits through the hole. Nope, let's make it wider. Now the specs are updated. They didn't waste $500 million on building that craft. Right? Now they have to invest in building a new type of wrench. So those are like basic applications. There's going to be all sorts of things in healthcare, with like surgery simulations, physical therapy, like different like house type of doctor visits. There's a lot of opportunities there. Other questions? Cool. I think we're done.